Oh yes, welcome back from that short break. Now we're doing question 5. This part Kamala once again, Memorandum 2025, grade 12, mathematics, paper 1, 2025. Yes, here at smartphymaths tutor center. You can attend on one, we can teach you in a group. Okay, so question 5 here, they say here that the graphs f of x equals to x squared plus bx plus c and g of x equals minus 4x minus 3 plus 8 are drawn below. So this is parabola, this is a hyperbola here. P, this point P is the turning point of the function and the point of intersection of the asymptotes of G as well. So this point P, turning point for the parabola and the point of intersection for the horizontal and vertical asymptotes here. They said that the graphs intersect at D, this point D is where the two graphs intersect. Then M and the T, this M and T, they are x-intercepts of the function f and g respectively. Write down the domain of G. The domain of G. Now our G is this hyperbola here, and I want the domain now. So what does domain mean to us, guys? Domain means what? Now domain, it is a set of x values that define the function, okay? So in this particular case here, if you look at our function G, this is our G here, né? This G here, this one here, the hyperbola here. This hyperbola here is our G. Now this hyperbola here, where is it defined? Okay. Now if you look here, this one is a vertical asymptote, né? This point here, which actually is going to be 3 because of this x minus 3 here. So this is 3 here. Now along this x equals to 3, you cannot find the hyperbola anywhere. So for that matter, but elsewhere you're gonna find, you can find it up here like this. Okay, if you touch it on this x-axis here, or you can find it somewhere here again. You see, so wherever you touch, you're gonna find the function there. So along these x values, né? All these x values here, these ones here, you can find it except here. Except here, you cannot find it because this is a vertical asymptote. So for that matter, our domain for this G, that is 5.1, is gonna be x element of all real numbers except what? Except, now when we say except, we say not equals to, except 3, okay? That's our domain here. Then next question here, they say here that write down the range of the function f, né? And on the range of this function f, I mean to ask guys, now the range, it shows us the y values that define the function, okay? So the range, the set of what? The set of y values defining the function here. So here we got our 3. Now here, now this point P is the turning point, which means the point which is actually 3 is to 8. This is 8 here, okay? So this point P is what? It is 3 is to 8, okay? So now the range, this is our function here, which is the parabola here. Now starting from this 8, let's see, this is here. Let me shade them in a green color here. Okay, the red is fine. Yeah, this point here, this is y value is here. Wherever I go, I find my parabola, right, guys? You can see that, for example, if I touch here at 7, I find it here. Touch at 0, I find it here. So wherever I touch, I'm going to find the parabola here, but I can't go beyond the 8. So that defines our range. And for that matter, it's going to be all the y values which are less or equals to 8. That's our range. Let us proceed. Then they say here next that determine the values of x for which g of x is what? Is less or equals to f of x here. Now, if we say g of x is less or equals to f of x, in other words, I'm not here. Okay, so this is our g of x. Now look at these intervals here, guys. So I have this one is a 5 here, right? This is 5 here. This is a 5 here. Let me divide my graphs into portions, okay? Along the what? The x-axis. So I have this one here, this one here, this portion here, and then this other portion here. this other portion here along the vertical asymptote, and then this other portion, this one here, when we're talking about x values, when I'm looking for the x values, okay. Now guys, look here. Now I'm looking for the x value such that my g is less than f of x. So now from this point M, from this M here, okay, up to this x equals to 3 here, okay, we see that the g is on top, but f is below. But I'm looking for where g is below and the f is on top. So I don't want this portion. Okay, I repeat. From this point M, for this x values here, from M up to 3, which one is on top? You can see the G is on top, but F is below, so I don't want that according to what this inequality here. But between the 3 until 5, okay, you guys can see that this one now, the function F, this F here, you see it is on top, and then our G is below. So mean that our but if I go beyond the 5, this is 5 here. If I go beyond the 5, now the G is on top and the F is below. So I don't want that. So my answer should be from the 3 until 5. So it's gonna be the x values starting from 3, okay, until 5. Until 5. Now I don't put equal sign here because this one here, the 3, it's an asymptote. So I can't put equal sign here, it won't be correct. So that is it there. Let us proceed. Now they say another one here. They say here that x values for which f of x is what? Less than 6, okay. Now this is the 6 here, 5 is to 6 here. Now if I may draw a line here, let's get some space here. If I may draw a line here, which is vertical, sorry, which is horizontal, okay, which is horizontal. Don't want this now. Done with it. Okay, so if I may draw a line which is horizontal, okay, you can see here that what? We can see that this line here, which I'm trying to draw now, trying to get something here, guys, don't worry. You see this green line here, which is dotted, this one here. It is passing through the 6. Passing through what? Through 5 is to 6, okay. So guys, this point here is point D, which is what? Which is 5 here, and then y equals to 6, because the y value is 6 at this point D. Okay, so now the question says that I want the x values whereby this function is less than 6, So starting from this point here, this very point here, going this way, you can see that the function f of x we're talking about is below. So I want these x values here. That's part of my answer. So here I'm gonna say that it should be when x is what? Is bigger than 5, right? As you can is below. Now this other side here, I want this x value here now. So now by symmetry, I want this value here, this x value here. Now by symmetry, this is a turning point here. So this is a 5, this one here is a 3, okay? So 5 minus 3, you get a 2. Meaning from the 3, I must have another 2 units here, So this must be 1. Why? Because 3 minus 1 is also 2. So 2 units and also 2 units here. So it means that now my other x value is going to be, now you see this parabola here, where I'm shading, it's below y equals to 6. So now the x values corresponding here are going to be less than 1. So it's going to be all x values less than 1. That's our answer here. Let us proceed. Then they say show that the equation of the parabola is this one here. Ne? So now that we have the turning point, please turning point form. Ne? Okay, so here I know that y equals to a into x minus what? X minus p, but p here is 3, okay? Squared plus q, but q here is 8, ne? So plus 8. Now that's a parabola here in turning point form here. So to get my function here, which they want here, I must find the value of a here. But I have this point D. The point D is what? It is 5 to 6, right? 5 to 6 here. So meaning my y is 6, okay? Looking for this a here. What about x? X is 5, ne? So this is 5 here. Minus 3 squared, then plus 8. Okay, so here now 6 minus 8, I'm going to get negative 2. And then what is 5 minus 3? 2 squared going to give us a 4. Then times a, it's going to give us a 4a. Now that's my a is negative 1 over 2. Okay, so I'm going to come back to get my function which they want here. That is a function f of x. Okay, will be given by what? By a, which is negative 1 over 2. Open brackets here. X minus 3 bracket squared, ne? Okay, then plus 8. So in here, before I bring the negative 1 over 2, let me first expand this. I'm going to get what now? I'm going to get x squared, okay, x squared minus 6x plus 9, okay, then plus 8 here. Now on open brackets here, I'm going to get negative 1 over 2 x squared. Now multiply by negative 6 give us positive 3x, so plus 3x, okay. Then negative 1 over 2 times 9, that's negative 4. Then plus 80, it gives us plus 7 over 2. Here, show that, guys. Hope we are together. That's how we show that. Next, they say calculate length of MT. Now my MT is somewhere here. This is my MT here. This is our MT here. This is our MT. Now T is the T and the M, they are both x-intercepts, ne?
Yeah,
So
okay. Question 5.5, it says calculate the length of MT. Now from M to T, as you can see, it is a horizontal line, ne? So if I can get my x at T and my x at M, then I can subtract the 2 to get my MT. So my g of x is the hyperbola, which is at T here, and then the f of x, this one here, it is one for M. So, but both at M and the T, y is 0. So I just need to find my x-intercepts here. Okay, so if I get them, I'm going to get my MT by subtracting xt minus xm. So at M, it's a hyperbola, the parabola, okay, M here. So at M here, I know that my y equals to 0. Okay, y is 0 at M. So I'm going to say that this is f of x equals to 0. Or I can say that negative 1 over 2, negative 1 over 2, into x minus 3 bracket squared, x minus 3 bracket squared, plus 8 equals to 0, right? Equals to 0. What is x-intercept, ne? Okay, so here, now instead of being a negative, it can cross over, or I can multiply, I can bring the 8 side, ne? I can say negative 1 over 2, negative 1 over 2, okay, into x minus 3, x minus 3 squared equals negative 8. Negative. So now here, multiply through by by positive what? Multiply through by positive 2. Okay, when I do so here, I'm left with x minus 3. I multiply into by positive 2 squared here equals to 16. 16 here positive. Now I can square root here, also square root here. So if I cancel the root with the square, and I'm left with the x minus 3. So x minus 3 here equals to plus or minus 4. Plus or minus 4. Now my m is on the left of the y-axis, so must be negative. So I'm going to say that x equals to 3. Okay, x equals to 3 minus 4, which gives me x at m as negative what? As negative 1. X at m as negative 1. Okay. Then the same way, to get my x at t, the hyperbola equals to 0, so I'm going to equate the g of x equals to 0. So I'm going to say that at point t, okay, I know y equals to 0, so I'm going to say that in this case, my negative 4 over 3, okay, plus 8 should give me 0, okay, because this is x-intercept. So now I can say that the 8 become negative this side, so I'm going to say, or I can print this side, I can say that 8 is equal to 4 divided by what? By x minus 3. Remember that the 4 was negative that side, now becomes positive. If I divide it by 4, when I get a 2 here, when I get a 2, I get a 2 here. Now I'm getting 1 here and then over x minus 3. So now if I do cross multiply here, I can say x minus 3 equals to 1 over 2. So to get my x at t, so the x at t is going to be 3 plus 1 over 2, which gives us what? Which gives us 3,5. Okay, 3,5 here. So that is my x at t, which is 3,5. Okay, so because I'm looking for mt, like I told you here, that then I must now subtract the x values. So I come back here. Our mt equal to the x at t minus the x at m minus what? The x at m. So if I do substitute here, now the x at t is 3,5, okay, 3,5, then minus negative 1, which gives us 4,5. So the 4,5 is our distance what? Distance mt. It is mt. Okay, all right. Yes, question 5,6 now. It says that determine the equation of the tangent to f at d. Now, guys, we want the equation of the tangent at point d to this function, which is the parabola here. Now, our tangent could look like this. Our tangent could look like this one here. Let me draw for you one here, and you see. I don't know if you remember, guys. What did we say a tangent is? A tangent is a line that touches the function at only one point. So in this case, this blue line which I'm drawing here, if it's going to be our tangent, then it should only be touching at point D. At point D only. Now at that point of contact, which is point D, this tangent should have the same gradient as the parabola. So at this point D here, the tangent, okay, M tangent should be the same as the M for the what? For the parabola. So M tangent means M means gradient, the same as M for the parabola means we're gonna differentiate and put x equals to 5, because the at point D x is 5. Okay, so here let's go ahead and differentiate now. If we do so, our function f of x, you see this one here. Now I'm differentiating directly here, so my derivative, okay, I'm gonna get now minus 2x here. This negative, né? That'll be minus 2x, okay. Okay, so divided by 2. Actually, the 2 is gonna cancel this 2 here, and then plus 3. Okay, so if I simplify here like this, function, okay, as what? As negative x plus 3, right, guys? Negative what? Negative 3. But then to get my gradient to be used in the tangent, I'm going to substitute where there is x, I'm going to 5, né? Because point D, the x is 5 here. Okay, so my m tangent, okay, the same as the derivative of this function at what? At 5. Okay, so put 5 now, it's going to be negative 5, then plus a 3, which gives me what? Which gives us negative 2. So because we have the gradient as negative 2, and then we have that point D, then why not? We can go ahead our equation for the tangent, because we know it is a straight line, okay? So this is 5 is to 6 here. Now here we can use y minus y1, okay, equals to m into x minus x1. So in this particular case, our y1 is this 6 here, it's going to be now y minus 6, y minus. Our m tangent, we already got a negative 2 into x. Now x1 is the 5, so minus 5 here. So when you open brackets here, what do we get? And simplifying, you're going to get our y equals negative 2, okay? Now, and this will give us positive 10, and then 10 plus 6, it gives us what? It gives us 16. So that is plus 16 here. And so that's our tangent equation. Alright guys, I think you should subscribe here to get more videos, don't you think so?